Okay, we are going to look now at graphing rational functions. So we've already kind of learned how to find vertical asymptotes and points of removable discontinuity. So if we look at number 1 here, number 1, neither the numerator or the denominator factor. So when I try to look at what can cancel, nothing can cancel. Some people think that these two x's right here can cancel. They can't, because in the denominator, you need to think of x minus 2 as one whole quantity, and you can't split that quantity up. So you can't cancel just part of it without canceling the whole thing. Okay? So nothing cancels. And so because nothing cancels, I know that there are no points of removable discontinuity. I'm just going to write this right here. Okay? So that much I know. Then I want to look for vertical asymptotes. And again, vertical asymptotes are the points that remain in the denominator, the factors that remain in the denominator. Well, I still have an x minus 2 in the denominator. And because I've had x minus 2 and then I set it equal to 0, I would get x equals 2 as a vertical asymptote. Okay, and I'll tell you how to deal with that on your graph in a minute. The horizontal asymptotes we need to look at as well, but we are going to use our graphing calculators to help us. So the first thing I want you to do is I want you to get this into your graphing calculator here. And I want you to go up to y equals. And you have to be very careful about how you put this in. You have to go x divided by, and you need to put the x minus 2 as a quantity in the denominator, or your calculator will not graph this right. Oops, I missed my minus sign here somehow. Okay, go ahead and hit graph. And your graphs sometimes become sort of pixelated. If your screen does not look the same as ours, as mine here, I want you to put a press zoom 6, and that hopefully will help you. You also might need to turn your stats plots off. So you might need to go second, y equals, number 2, enter. Try those two things if your calculator's not working. Second, y equals, number 4. Did I say number 2? Number 4. Second, y equals number 4, enter. Try that. And then to get your screen the same as mine, try zoom 6. Okay, and hopefully your graph will look like mine. All right, here's what it looks like. You can see the vertical asymptote right here on the graph. The other thing that happens is if you go to your table, which I'll do for you in a minute, but if you go to your table, you can see your vertical asymptote. On mine, I'm not even going to pull my table up right now because it's showing right here. See how I have an error right here at 2? That's because the function is not defined at 2, and so it's giving me an error at 2. Okay? So I'm going to just get rid of these so they don't mess everything up. If I go to my table now, we're going to use our table to help us. Clearly you can see that error at 2 as a vertical asymptote. Okay, then it looks to me, just by looking at the graph on the calculator, that there's probably a horizontal asymptote too, because there's a line right here that neither one of these branches seem to ever touch. And the key is to figure out where this line is at. What's that value that that line is at? Okay? And so what I'm going to do is I'm going to just kind of go to my table, and I'm going to go really low on my table here, and I'm noticing in my y values that my numbers are getting bigger, and they're getting, for instance, in this case, my numbers are doing 0.90, 0.91, 0.92, 0.93. So they're slowly getting bigger, and if I kept scrolling up, they would never, ever, ever, ever reach 1. Okay? If I go the other direction, and I'm going to just kind of get button happy here and let this catch up to me a minute. If I go the other direction, now my numbers are getting bigger and bigger and bigger, and they're over 1 right now. But if you go down here, let's go back this way a little bit. There is never a spot where my graph is exactly at 1, okay? And so it seems to me that I have a horizontal asymptote at y equals 1, okay? And if I press the graph, this is what it should look like. So I have a horizontal asymptote at y equals 1. Okay? So when you graph this, what I want you to kind of do is I want you to sketch your asymptotes in. Here's your vertical asymptote right here at x equals 2. So draw that in. And then draw your horizontal asymptote in right here at y equals 1. And then, of course, just kind of sketch your branches in. If you want to get some exact points, you can certainly go to your table and plot some exact points if you would like. But otherwise, just sort of sketch your branches in. I'm not too terribly concerned about that. Okay, so that's how that one goes. All right, on the next one, our function does factor, so I do want to look at that first because it will help me to deal with it algebraically first, and then we will worry about the rest of it. Okay, so this one factors up here as x plus 3 and x minus 3. The x plus 3's are going to cancel. Excuse me here. All right, and again, factors that cancel give you your points of removable discontinuity. Okay, so I know that this factor is going to cancel at, or it cancels at when x is negative 3. So when x equals negative 3, there is removable discontinuity. Okay. Then I want you to notice that I have no factors remaining in my denominator. I have nothing left in my denominator. So there is no vertical asymptotes because nothing remains in my denominator. I'm going to just write this out. No vertical asymptotes, and I'm going to write no factors left in denominator, so that when you go back to your notes, you know that what that is, where that's coming from. Okay, so I've got that, and I've got that, and I'm going to deal with the horizontal asymptote when I put my function into my calculator. Now, when you put your function into your calculator, you need to put the original function into your calculator. So you need to put the x squared minus 9 on the top and the x plus 3 on the bottom. And when you do that, you need to make sure you use parentheses. So I will show you how to do this here. But you're going to put in x squared minus 9, that whole quantity, put that quantity in parentheses so that your calculator doesn't get that mixed up. So the quantity x squared minus 9 in the numerator, and then divided by the quantity x plus 3. Okay? And then I will hit graph. And when you graph it, it looks something like this, but you need to know that your calculator gets kind of pixelated and it doesn't show up. If we go to our table, what I want you to notice is that at negative 3, there's an error, and there should be an error because we figured out that negative 3 was a point of removable discontinuity. It doesn't show up very well on your table because it does get so pixelated, but here's what it looks like. In this particular case, this is just a line. It's a graph that's a line. It has no horizontal asymptote because everything approaches positive infinity and negative infinity. We already know it doesn't have a vertical asymptote, but it does have that hole at negative 3 when you look at your table. So here's what your graph should look like. Okay, you can get some points to plot from your table. So if I go back to my calculator, I can certainly plot the point negative 2, negative 5, negative 1, negative 4, 0, 3, so that you get that exactly right. But, and of course it's a line, so plot some of those points, and then just make sure that you make a hole at x equals negative 3. So I would have graphed the line like this. Okay, that's how you're going to do it. And then I find where x is negative 3 along my x-axis, so x is negative 1, negative 2, and negative 3. I go down until I hit the graph, and I need to make myself a hole at that spot. So just show me somehow that there's a hole at x equals negative 3. There are no horizontal asymptotes in this case because there is no place where the graph is approaching a horizontal line anywhere. Okay? Okay, a couple more here that we'll make sure that we go through and be okay with. So there's this one. And then this one down here factors, of course, as x and x, and 3 and 7. And they will both be minus here. Okay. The x minus 7's cancel. And because it cancels, that means that there is a point of removable discontinuity at x equals 7. So there's a hole in there. Okay. Also, a factor remains in the denominator, and that will give us x equals 3. And that, of course, is a vertical asymptote, so I should be able to draw a dotted vertical line at 3. The graph will approach that line, but never touch it. And then the horizontal asymptotes I will get from my calculator. So I'm going to put this in. And again, you need to put the original function in, not the part after it's been factored, because that's not going to give you all the information you need. So you need to put the quantity, x minus 7 in, divided by the quantity x squared minus 10x plus 21. Okay, and I'm going to go and graph that. And here's what it looks like. And again, your calculator does get kind of pixelated, but hopefully you can picture that this line goes on forever and ever, and that this branch is kind of doing this, and this branch is doing this, and it looks like there's a horizontal line at 0, but we're going to check that out with our table. Okay? So, when we look at our table, we should have an error at x equals 3. So let's go check that out. Oops, I want to be on my table. Okay, so let's see. And we do have that error at x equals 3, so it's right there. That's good. Okay, and then I want you to notice that it looks like we have a horizontal asymptote at y equals 0. Does y ever equal 0? And if you scroll all the way down low like this, you can see that your numbers are getting closer and closer and closer to 0, but they never actually touch 0. You will never approach 0. Okay, so you have a horizontal asymptote at 0 here. Okay, and you're going to get that from your table. So y equals 0 is your horizontal asymptote. Okay, so let me show you what this graph looks like. All right, so you've got your horizontal asymptote at 0. You have your vertical asymptote at 3. You have your 2 branches there, and mine get a little pixelated here too, so I know it looks like my branches cross my asymptotes, but they don't. And then you need to make sure that you make your hole right here where x is 3. So I went to the graph, I figured out where x is 3, and I made my hole at that spot. All right. Last one here. We have 4 over x minus 1 squared. Okay? So nothing cancels here. I can't factor the top, so nothing cancels. And so I have no removable discontinuity here because nothing cancels. I'm just going to write this so that we remember. Okay? I have a factor that remains, and I actually have 2 factors that remain because this is x minus 1 and x minus 1, although it's a double spot, so it doesn't really matter. But so x equals 1 then remains, and so that will be a vertical asymptote. So I'll have a vertical asymptote at 1, and then of course I'm going to check my graph out to see if I have any horizontal asymptotes. Okay, so I'm going to go to my calculator. I will go up to y equals. I will clear this baby out, and I will put in 4 divided by the quantity, and it was x minus 1 quantity squared. I'm going to delete this too. All right, and hit graph. And here's what this one looks like. So you can see that you have 2 branches that are actually both on the top in this case. And you can see your vertical asymptote here, like we said, at 1. So here's your vertical asymptote at 1. You can see that from your graph. And it looks like there's a horizontal asymptote at 0. And if you go to your table, I want to just see evidence that x never ever really reaches 0. And you can see that that's already happening down here. And again, my numbers are getting smaller and smaller and smaller and smaller and smaller down here. I could go on forever and ever. But they're never going to exactly reach 0, okay? So that's what your horizontal asymptote is. If you do the graph on this one, it will look like this, okay? Again, vertical asymptote at 1, horizontal asymptote at x or at y equals 0. I should put that in there. Okay, so it never ever ever touches the y equals 0 line. There are no holes in this one, so you know you don't need to worry about that, and this is what that graph should look like.